In the previous video, we looked at how we can determine the number of significant figures. In this unit, we are going to look at how you can round off numbers, that is, into their right significant figures. So we'll be looking at rounding numbers. So when you perform calculations involving measurements, you need to know how to handle significant figures. This is especially true when you are using calculator to carry out mathematical operations. So the answers given on a calculator can be derived results with more digits than are justified by the measurement. Suppose you use a calculator, for example, to measure a value of 154 gram. By a measured value of 327 milliliter. So each of these values has three significant figures. Each of these has three significant figures, as you can see. Each of them is having three significant figures. The calculator would show a numerical answer which is different. So let's see what the calculator will show. Let's go through and see what the calculator will show here. If we have those numbers divided, the calculator might show you something of, so 154, we divide it by 327. This is what the calculator will show you. It will be a number with a long digit. So the answer contains digits not justified by measurements used to calculate it. So such an answer has to be rounded off to make its degree of certainty match that in the original measurement. The answer here should be 0.471 grams per milliliter. And note the previous number which we found on calculator, which was 0.470948012. So we round it off to three significant figures. So the rules for rounding are shown in the figure here. We have rules. We don't just round, but we have to follow rules. So rules for rounding numbers. If the digit following the last digit to be retained is, so this column will be showing this, and then this one here, then the last digit should be, this will show what the last digit should be like, and the third one, the number rounded to three significant figures. So here we are rounding the number to three significant figures. So greater than 5, so if the digit following the last digit to be retained is more than 5, like this is the number we are going to deal with, So we look at this number here. If it is more than 5, it should be increased by 1. So if you increase 6 by 1, you will get 7. If you increase 6 by 1, you will get 7. The next one, less than 5. If it happens that the number is less than 5, like in this instance here, so what are we going to do? Stay the same. So the number will stay the same. It was 3. It will remain 3. 5 followed by a non-zero digit. So if the next number is 5 followed by a non-zero digit, so this is non-zero because it's 1, and this is 5. So you will increase by 1, and you'll get 9, 8, 7, 2.78. 5 not followed by an non-zero digit and preceded by an odd digit. If it is preceded by an odd digit, like in this case here, we are having 5 and it is preceded by 3. 3 is an odd digit. Because 3 is an odd digit, what will we do? We will increase by 1. So if we increase the 3 by 1, it will become a 4. Why? The reason is because 3 is odd. 3 is odd. Then if we are having 5 not followed by a non-zero digit and preceded by a significant digit which is even, it will stay the same. If it is preceded by the number here, for example, that precedes this number is even number. So if it is preceded by an even number like this is 8, so what will happen is, preceded by 6 rather. So what we will do to this number, it will remain the same. If it is preceded by an odd number, we will increase by 1. If it is followed by a non-zero number, so this is somehow confusing because here it is not being followed by anything. So you should note this point here, that here it is not being followed by anything, but here it is being followed by a number. So if it's not being followed by anything else, that is when we look at the preceding number. But if it is followed by another digit, then we see if the digit that follows it is a non-zero number, then we only look at this number. If it is 5 and above, then we'll increase by 1. If it is 5 not followed by a non-zero digit and preceded by an odd digit, then it will increase. If it is preceded by an even digit, it will remain the same. Those are the rules for dealing with significant numbers or rounding off significant numbers. The next thing that we are going to look at is addition. We'll be looking at addition or mathematical operation, and we'll be looking at addition and subtraction with significant figures. So consider two mass measurements. For example, you are having 25, not 2, but rather 25.1 25.1 gram, and 2.03 gram. The first measurement, 25.1 gram, has one digit to the right of the decimal point. It has one digit to the right to the decimal point in the 10th place. There is no information on possible values for the 100th place. So for 100th place, we don't have any information about it. So here we don't have any information. We don't know if it is 0 or whatever it would be. We are not told here. The other measurement, 0.03 gram, has two digits to the right of the decimal. As you can see here, it has two digits. It provides information up to and including the 100th place. So suppose you were asked to add the two measurements. Simply carrying out the addition would result in the following figure. Okay, let's try and add. Then we see what we will get if we are adding this. 25.1 gram plus 2.03 gram. So if we use our calculator, this is what we will get here. 25.1 multiplied by 2.03, we will get 50. Rather, we multiply, what we will get? I think we make a mistake. Maybe we multiplied, we were supposed to add, sorry. So we have 25.1 plus 2.03, we will get 27.13 gram. So we would get 27.13 gram. So this answer suggests that there is certainty all the way to the 100th place. However, the result is not justified because the 100th place is supposed to be only 25.1 gram is completely unknown. So this answer is not justified because it is giving us the 100th place, yet in our example we don't have it in one of the figures. So the answer must be justified to reflect the uncertainty in the number added. When adding or subtracting decimals, the answer must have the same number of digits to the right of the decimal point as there are in the measurement having the fewer digits to the right of the decimal. So you should note that point, which is saying here, when adding or subtracting, decimals, the answer must have the same number of digits. To the right of the decimal point, to the right of the decimal point, to the right of the decimal point as there are in the measurement, as there are in the measurement, as there are in the measurement, having the fewer digits, having the fewer digits, having the fewer digits to the right of the decimal point, to the right of the decimal point, to the right of the decimal point. So this one is the one with fewer digits. This has more digits. So we are supposed to compare this, and not this one. So we are saying when adding or subtracting decimals, the answer must have the same number of digits to the right of the decimal point as there are in the measurement having the fewer digits to the right of the decimal. So when we compare the two values, the measurement with the fewer digit to the right of the decimal point is, in this case, if we are comparing them, it will be 25.1 gram. Because it has one such digit. So following the rule, the answer must be rounded so that it has no more than one digit to the right of the decimal point. The answer should therefore be, in this case, 27.1 gram. So this should have been the correct answer. So we will continue in the next video. For this video, we'll stop here.